All right, so you should get there and you should see a question that talks about brownies. So we're going to kind of be reviewing some of the pieces of the scientific method that we talked about on Friday. So while you're still getting there, I'll read this out loud and you guys can answer the first question. So you heard from your grandmother that if you store a piece of bread in a storage container with some brownies, the brownies will stay fresh longer. So you decide to test this idea and bake a batch of 6 brownies. Then you place each brownie in a separate container and place a piece of bread in 3 of those containers and leave the other 3 containers without bread in them. So over the next week, you collect data to see which brownies stayed the freshest. So what is the hypothesis in this scenario? So remember, the hypothesis is the if statement. Then here, what goes in there is what I want to change. What do you want to change in an experiment? Goes there. Then, all right, what you expect to happen. That's how an hypothesis looks. So if what I want to change about the experiment. So what in this experiment are you changing? Then what do you think will happen? And submit. So if, what do you want to change? What do you think, what are you testing? Then what do I think will happen? All right. Tyreek, good answer. Okay. All right, we're getting there. Good. Carmina, very good. All right, so I'm seeing some good hypotheses here, and I'm even seeing a reverse one. All right, so here's an example of some of the good ones. All right, so I'll give out a few of them. And if I don't share yours, that doesn't mean it wasn't good. I'm just sharing ones that really hit the nail on the head. All right, so here, if I put a piece of bread with 3 brownies, then it'll stay fresh longer. Excellent. All right, here's another one. If I put a piece of bread in one of the containers, it will be more fresh than the brownies that do not have one. Oop, I didn't share it. And then here's the reverse one. If I don't put bread in neither of them, then all 6 brownies will be old. All right, that's good. So then that's thinking, all right, if I don't put bread in there, then they won't get old. So we have the hypothesis is that if we put bread in the containers, then they will stay fresh longer. All right, so in this example, what is the independent variable? So what is the thing that we are not that we are choosing to change? So what part of the experiment are we choosing to change? What are we testing? What are we choosing? That's the independent variable. The thing that will not change as the experiment goes on. So we've started with the hypothesis. We want to see how putting a piece of bread in a container affects the freshness of the brownies. So what are we doing to try to see the effects of? All right, so I'm seeing some people put down the brownies. What about the brownies? What are we doing to the brownies? Good, Carmina, you got it right. All right, good, we're getting it. All right, good. All right, I'm gonna share a few answers, so make sure you hit submit. All right, so the independent variable is real simple. If the container has bread or not. All right, so we are adding bread to see if the results change. Okay, we are choosing to add bread and putting them in separate containers. So good. The bread that we add is the independent variable. It's the thing that we are hoping affects the experiment. Very good. So now the dependent variable. What is the dependent variable? What do we think is changing because we added the bread? So this is what changes because of the independent variable. What is changing because of the, I can't spell today. So what is changing and what are we measuring? That's two ways to look at it. So what is the answer to this question? That's what you type in there. So what thing is depending on whether the bread is in there or not? All right. All right. Sincere, you had your answer right the first time. All right.
I don't remember what I had.
All right. All right, Terrence, spot on. All right, give you guys a few more seconds. Carmina, very good. Todd, good. All right, we're getting there. All right, go ahead and hit submit because I want to share these answers so we can keep moving. All right. In the simplest form, all right, the freshness of the brownies is the dependent variable. That's the simplest you could put it. All right, the freshness of the brownies is what we're measuring. So the independent variable is the bread in the container. The dependent variable is the freshness of the brownies. So how fresh will the brownies be? Very good. So in order to determine how fresh the brownies will be, what are we comparing the freshness of the brownies to? So when you do an experiment, it's called the control. The control is the thing that you compare the experiment where you change something to it. For example, if you wanted to see if you had a plant, you wanted to see if you played music for the plant, if it would grow more than if a plant that did not have music. So you set up 2 plants. You got to have one that you play music to, and then a second one which you compare it to, which is the one that without the music. So that way, after they grow, you can determine, all right, I changed this thing with this one. How do these results compare to the thing where I didn't change it at all? All right. All right, Sincere, perfect, good job. So what are we comparing it to? What are we comparing the brownies that have the bread in them, the ones with, what are we comparing them to see if they are fresh or not? All right. So we are comparing the freshness of the brownies with and without bread. That's what we're comparing. All right. So now that we've broken that down, those are the components of a scientific experiment. Speaking of experiments, but don't answer this yet. I'm going to explain it first. So what I want you to think about is on Friday, we watched a video where we had a candle in a jar and it sucked up water into the jar. So I listed 5 of the most requested experiments, the most common hypothesis. So of these 5, all right, we're going to choose one to be the class hypothesis moving forward. So for the rest of the time today, we're going to talk about one of these being the class hypothesis when I refer back to it. So choose the one that you want to see be the class hypothesis. So if you increase the size of the jar, then more water will be absorbed. If you change the color of the water, then more water will be absorbed. If there's more water in the pan, then more water will be absorbed. If you increase the size of the pan, there'd be more water absorbed. And then finally, if there is a larger flame in the jar, then more water will be absorbed. So choose one of these 5, and the one that gets the most votes will be the one we move forward with. So go ahead and vote now. All right, a few more minutes or seconds. Okay. All right, so the winner by a lot is if there is a larger flame, then more water will be absorbed. All right, so moving forward, this is the hypothesis we're going to operate with, that we are going to be testing this. But I also had a bunch to compare it to. All right, so I conducted each of the 5 experiments, and now we're going to look at them. All right, so in this video, how this should work is it'll play up into a point, and then it'll stop and ask you a question. When you get to the question, you answer it. Pretty simple. All right, so go ahead and hit play. You can watch this on my screen or do it on your own. All right, so first off is changing the color. So I have 250 milliliters of a blue water. I fill up the dish and then light the candle. And we got the jar. All right, so what I want you to do is I want you to pay attention to where the line on the jar is approximately. And how did that compare to the one we saw on Friday? So this is the line right here I want you to think about. All right, so what was the effect of changing the water color on the height of the water in the jar compared to the control? So the control is the one we saw last week on Friday. Do you think the height of the water decreased, height of the water increased, decreased, or stayed the same, or there was no significant change? So that means there's no like huge difference, all right? So if you think it was, yeah, that looked about the same, then that's your answer. All right, so let me see. So if you need a reminder, let me go ahead and try to share this real quick. No, it's not gonna work. All right, so when we look at it, there was no real difference. Now, it may look a little different, but we're talking about a few millimeters or milliliters of difference. So no, there wasn't a real significant change. All right, so next up, I'm going to change the size of the jar. So I have a round jar now that I'm going to play with. All right, we're going to put it over top the candle. And again, watch the think about that compared to the other jar as well. All right, so look where that wound up, right about here. I would say it's like a quarter of the way up the jar. All right, and then finally, I got a third beaker. Right here. All right. So, was changing the size and the shape of the jar, what was the effect on the height? So was there no significant change? The water was less on average, or there was more water on average? So think about like in general, when you change the size of the jar, how did that affect the amount of liquid that got into the jar? Was it about the same, or was it more, or was it less? All right. All right, so this one's kind of split. A lot of people are either saying that there was no significant change or it was a little bit decreased. So I would say it would still, in general, is not a significant change. It may be a little bit, but not enough where I think it matters. All right, next up, we're changing the amount of water. So I'm going to add another 250 milliliters of water to the pan. and do the same thing. So you can see on my screen that there is more water in the pan. I'm doing the same thing. Zoop. All right, so I know you can't see the bottom of the jar, but it's right about at the lip of the pan. So again, think about how does this compare to the other ones? All right. So how much water was, so adding more water, was there a big change? No change. All right. Make sure you're answering. All right. So see again. All right. No big change. All right. Now we're going to change the size of the pan. So I'm going to use a larger pan. So I filled up a large container to see what that would do. And then did it from there. So again, pay attention to the approximate height of the water. Because we're just basically comparing it. Now, if we wanted to get really specific, we would have taken like I would have taken a ruler and measured it each time, but I just thought getting the point across was important here. All right, so what effect did changing the size of the pan have? Was there a significant change, decrease, or an increase? All right, good work, guys. All right, make sure you answer up. All right, so the vast majority of us said there was no significant change. All right, now we're gonna move on to the last one where we have an increase in the size of the flame. So changing the size of the flame. I stuck 3 candles together so it'd make a larger flame. and lift them up. Put the jar over top. Hey now. All right, so watch that last part again. Pay close attention to where the water goes to. And think about how that compares to the other one so far. Okay, so what was the effect on changing the size of the flame on the height of the water? It increased the height of the water, it decreased the height of the water, or there was no significant change? This one should be very simple. All right, waiting for a few people. Edwin, Todd, George, answer up. Always one. All right. This one, very clear that the height of the water increased. Very clear. See? The height of the water increased. So which independent variable caused the most change in the amount of water absorbed by the jar? Color of the water, size of the jar. Wait a minute, guys. Hold up. You guys are just clicking what the last answer was. So make sure you read them. Changing the size, the color of the jar, the size of the jar, the amount of water in the pan, size of the pan, or the flame in the jar. All right, so make sure you click on the right one. Don't just click A again. So which one had the most change in the amount of water absorbed by the jar? Good work, guys. All right. Todd, need you to answer. All right. Correct answer was the size of flame. Everybody got that right. All right. So now we're going to come to a conclusion. So we're going to talk about what we saw. All right. So we just concluded that the one that had the most effect on the amount of water in the jar was the size of the flame. So when you take a conclusion, you want to look back and look for patterns and relationships in your data. So our data was observational this time, but sometimes we have data that's numbers like distances, weights, volumes, things like that. So you want to look for patterns in those and then think, does what we gathered support the hypothesis? Now, it's very, very, very important for you to know it does not always work out that way. Your data might not support your hypothesis, all right? In one of my other classes today, it did not. And that's okay, because you can still learn something if your hypothesis is wrong. Remember, your hypothesis does not have to be right. Does not have to be right. All right, so did the data we saw today, did it support our hypothesis? Remember, our hypothesis was that the flame, if you increase the size of the flame, then you will have more water in the jar. That was our hypothesis. If you increase the size of the flame, then more water will be absorbed into the jar. That was our hypothesis. So did what we observed right before this, did that support or not support us? All right. Make sure you get your answers in. Waiting for it. Let's see, Todd and Tyreek, and whoever physical science is. I don't know who that is. All right. So it is clear that, yes, our data was supported, did support our hypothesis. One person thought no, but our data did. So we saw that when you added more flame into the jar, more water was absorbed. If we would have said anything else, if we would have thought that anything else, like say we thought the size of the jar affected the amount of water in the jar, then our hypothesis would have been no, it would have not been supported. And again, that is okay, but as long as you learn from it and you understand why it wasn't supported. Again, it's okay for your hypothesis to be wrong. It will not affect your grade if your hypothesis is wrong. All right. So, with that in mind, science never solves problems without creating 10 more. All right, so sometimes when we solve the problem of what causes more water to be absorbed into the jar, we figured out why or what that is. All right, but normally when you do an experiment, it creates more questions. So now that we understand that more flame equals more water in there, then that should pull up some more questions for you. Be creative. Think about it. All right, because that's what the last question is. So what are some questions that this experiment brought up for you? Use your imagination and be curious. All right, science should make you curious. When you see something happen in the lab or we work on a project and we come to a conclusion, you should be like, wait a minute, why? Why does this happen? What if we did this? Or so like you could say like, if how many candles would it take to fill up the whole jar with water? Could be another question. So those could be things that you could write down. So be creative with this. There's no wrong answer for this one. I want to see what questions this pops up in your head. So go ahead and answer that. All right, I'm seeing some good ones. You got to have something. All right, I'm asking you to come up with one question. All right, so Sincere and Will, come up with something. Come on now.
I don't got nothing.
You're saying that because it's the easiest answer, not because that's true.
There you go.
All right, good. All right, I got some good ones. All right, so I'll give you guys a few more seconds to finish typing before I start sharing. All right, here's some ones that I like. All right, Joshua, you had a great one. All right. Well, it's amazing how 3 candles almost filled up the jar. I wonder if you had put 6 candles, would it fill up the whole jar? I noticed that every experiment the jar gets foggy at the top. Why is that? That's awesome. 2 great questions with legitimate curiosities to find and go find that out. All right, let's see. What if you used a smaller container? Would it fill it all the way up? That's a good question. All right. I like this one too from Tyreek. All right. So I really only have one question. On a bigger scale, does it still work if the flame source is big enough? So like he's asking, what if you used a giant flame in a giant jar? Like what if we use like a gallon jug, you know, and a big flame? You know, would it still work? That's a great question. That's oftentimes that's how things start on a small scale, and they try to find big scale applications. So that's good. So this one's a good one too. All right, I don't have any questions, but why is the experiment today? But why didn't you try no water? That's good too. All right, good stuff. There's some cool things that we could do. I had someone in my other classes suggest we do it with something other than water, like an oil or salt water. That's awesome too. So those are some things that's how you should start thinking scientifically is, all right, so we did this thing, now what? All right. And I encourage you to try this at home. This is something you can do real easy at home. All you need is like a dish, a jar, and a candle. That's it. All right, you can do this at home. It's safe. Just don't burn down your house, okay? Because you can't blame that on me. Don't burn down your house. Maybe do it outside. And you can do something, try this at home. You can try this out. Try a bigger bottle. Try a salt water. Try a bigger flame. Try something, you know, have fun with this. You can do this at home. All right, so that's all I got for you guys today.